Hello everyone, my name is Thomas van Gemert and today I want to talk to you about how we assess virtual reality sickness in walking-based locomotion for virtual reality. One of the main challenges with walking in virtual reality is the limited physical space a user typically has available. To overcome this limitation, researchers and designers have developed walking-based locomotion techniques that redirect the user through the physical space by manipulating the virtual motion or the virtual environment. We refer to this as redirected walking. Redirected walking comes in many different flavors. As part of this paper, we developed a taxonomy that groups different types of redirected walking together based on what type of manipulation, motion manipulation or environment manipulation they employ. Isometric walking on the top left is just normal walking. Redirected walking then consists of several different variants that we study in this paper. For example, resetting means that you walk to the end of the walkable space, turn around physically 180 degrees, but virtually, for example, you turn around 360 degrees. Scene manipulation means you manipulate the environment to steer the user through the physical space, for example, by warping the path in a certain direction or by using self-overlapping spaces. Reorientation is a very popular redirected walking technique that uses perspective manipulation. In particular, rotation gains are applied that rotate the virtual world ever so slightly so that the user physically starts steering through the space, but virtually thinks they are still walking in the correct direction. Repositioning is one of my personal favorites, where you apply a gain to the user's translation in virtual reality, making them walk much faster or slower, allowing them to cover different distances than in real life. What all of these techniques have in common is that they produce a mismatch between the motion you see in the virtual environment and the motion you feel physically. And this can cause virtual reality sickness. Virtual reality sickness is a form of motion sickness that affects many users, and it is one of the key factors that affect VR experiences and prevent good experiences in virtual reality. Despite decades of research on motion sickness and VR sickness, it is still a problem. It is notoriously fickle, ill-defined, and difficult to measure, so it would be helpful to investigate how VR sickness is assessed in VR locomotion research. However, it is not clear how we should study VR sickness and how we should interpret the results, given that there are many different study designs and procedures and incomplete data reporting. Second, despite existing reviews and previous work on VR locomotion, we don't know how different types of walking techniques that use different types of manipulation affect VR sickness. These are the questions that we address in this paper. Because there is already a lot of research on walking-based locomotion, and that research often includes a measure of VR sickness, doing a systematic review is a good idea so that we can compare multiple papers and draw conclusions from a general body of work. Additionally, we want to combine the VR sickness measurements in a meta-analysis to synthesize the effects for different types of walking-based locomotion. The systematic review was done by searching for papers that present a user study where the user wears a virtual reality headset and physically walks through the space and a VR sickness measure is recorded. We searched for papers in the 4 databases that publish work on virtual reality, and because we had quite a broad search query, we found 2091 papers in the identification phase. We then performed screening and selection, and we selected based on 10 exclusion criteria. For example, we only included papers between 2016 and 2022 to use only more recent virtual reality hardware and align this with the release of the HTC Vive and the Oculus Rift, for example. We also only included papers that used physical walking and where the user actually physically walked through the space during the study. We also excluded papers that did not report a numerical measure of VR sickness. Finally, we were left with 96 papers that satisfied our criteria, and these papers were coded by all the authors to extract the data and used in the meta-analysis. The results of the meta-analysis are rather difficult to interpret, so we leave those to the paper. There was a lot of variance, and the results overlap to some degree between different study types, so we need to be careful in how we interpret these differences. We do that in the paper by providing a discussion on how to interpret VR sickness scores and guide the reader through the interesting points that we find between techniques and between redirected walking techniques and normal walking. What I do want to discuss now, however, is what we learned about VR sickness measurement. We found that the simulator sickness questionnaire is by far the most common measure of VR sickness, but it is not a suitable measure of VR sickness. Issues around the validity of the simulator sickness questionnaire are already well known in the literature, but still, the SSQ remains the most used measure of VR sickness. We additionally found in our paper sample that the reported scores are misleading and often diverge from what other VR sickness measures report. This means that they are misleading in that they don't accurately portray how much discomfort the participants in that study had as a result of VR sickness, or as a result of the exposure to the locomotion. Second, we found that the simulator sickness questionnaire is difficult to use, and the scores are often not reported correctly. We found several instances of incomplete scores, incomplete reporting, incorrect calculation of the scores, inconsistent procedures, and more. As a solution, we provide a comprehensive discussion on how to interpret simulator sickness questionnaire values and how to use the simulator sickness questionnaire if you must. However, we also stress that using the simulator sickness questionnaire should be avoided where possible, as it is not a good measure of VR sickness in modern virtual reality systems. Finally, we provide several guidelines based on previous work and our own work that help future researchers make better decisions when they want to study VR sickness in their VR locomotion designs, and that aid designers in interpreting the results in current work. In conclusion, we found that doing a meta-analysis on these studies in our paper sample produced some limitations. The amount of variance and the amount of differences between study designs made it so that it was difficult to provide strong combined effect sizes. The distribution of scores and some differences are still interesting, and these are discussed in the papers, but if we want to determine how different types of walking-based locomotion affect VR sickness, dedicated studies are needed. The main strength of this paper is what we learn about how VR sickness is assessed at the moment and what the problems with that are and how we can do better. This is provided in the paper in the form of an extensive discussion and guidelines. Thanks to the insights in this paper, we can greatly improve how we interpret and study VR sickness, which is one of the most important factors affecting the user's experience in virtual reality. I'm happy to discuss this work further in person at the conference, or you can reach out to me on my email address on the slide. Thank you.